Welcome everybody, I'm Enrico Bassi, manager of OpenDot, one of the partner in the distributed design platform, and professor of digital fabrication and industrial designer as a background. So when I started first industrial design, I was very interested in understanding how can we design more sustainable products, and I realized that that path led to companies that sometimes has a good vision about sustainability, but in other cases they might be less interested in that. So I took a different turn. I started to coordinate the first Fab Lab in Italy back in 2011 and tried to work towards a more sustainable future together with people and not necessarily starting from the companies. Not because the companies are not fundamental, they are one fundamental partner in these transformations, but without changing the people, the users, every one of us, it becomes really difficult to actually have a proper, stable, resilient transformation towards a more sustainable future. So, what we're going to talk about today, it's really what a Fab Lab can do in the sector of sustainability, and in particular within the framework of circular economy. So first of all, we have to define what circular economy is and how this concept changed during the years, becoming something now kind of well known and pretty stable, even if the definition is constantly evolving. Now, the definition of circular economy is strongly related to companies and, again, economy, but there are some principles that could be applied to the maker movement and the Fab Lab network as well. Actually, Fab Labs and makers can have a role that nobody else could have in this ecosystem. So, first of all, what's circular economy? Well, it is an economical model, first of all. So, we are talking about how can we be profitable or at least economically sustainable without extracting from the planet more than what the planet can actually provide. So, staying within the boundaries of what is sustainable. Technically speaking, an infinite long time. So the idea is really to create something that will not have a long-term impact. Now the definitions, as we said, are different, and we will not necessarily get into the details, but it's interesting to see that circular is in opposition to linear. So the previous model was the model of a linear economy in which you start extracting material from the planet, transporting these materials somewhere, produce something with the material that you extracted, and material of course also means energy if we think about oil, for instance. Then these products get sold to people that they use it for a while and then they just throw it away. Now this is called linear because of course the end point is not the same as the starting point, and therefore the image of linear. From this it's clear what's the difference when we're talking about circular. So the idea is that whatever we take, it's gonna get back to the same point it started in. It doesn't mean, of course, to put back the material inside mines, but it means to valorize every transformations that we have along the process. So let's just analyze briefly what it means to have a linear economy. First of all, think about a mine, an extraction site. We have to deal with the disruptions of the nature, social problems around the area. We create jobs, but these jobs are not particularly resilient. You don't create skills that people can use in other areas. We have to think about not just the waste that we produce immediately while we extract the material, because a large part of what's extracted is actually not what we want, so it's thrown away. So we have to deal with solid waste, but also liquid waste. So whatever it's created when, for instance, it's raining and some of the toxic elements or polluting elements get washed away. At the end of the process, when the mine is not useful anymore, what's going to happen with the site? Is it going to be a big hole in the ground with no plants, no vegetations, no animals that can live there? So also thinking about how to extract materials from the planet is fundamental. And of course we need materials, so it's just a matter of how to extract them. Now the key point here is that there doesn't exist one single sustainable material. Sustainability, it's really a matter of compromising. So we have to understand which one is the best material for that specific job. For instance, having something super resistant and lightweight like carbon fiber might be amazing for a vehicle in which the weight is strongly correlated with the consumption of energies and raw materials, but it might not be as important when we're thinking, for instance, about building furniture or something that doesn't consume energy or consume more energy if it's heavier than what it should be. Now the second step is transportation. Now whatever we extracted somewhere needs to be brought where it's going to be transformed and where the factory is. We got a great example in this picture with what could happen with transportation. So just a single ship gets stuck in the middle of a very trafficked area, might compromise for months the global system of distribution of goods. This is just a small, simple proof of how fragile our global interconnected system is. Plus, it's a very polluting system. Up to 7.5% of the total amount of green gas emissions are actually related to transportation. This is not something sustainable, and being circular, it's strongly connected also with being local and understand and have the capability of transforming things locally and make them last longer. Before a product become a product that could be actually used, it needs to go a long step of processes that includes transformations, injection molding, industrial technologies, and so on. Now these steps are usually quite efficient because no company has interest in wasting energy and money in that, but it's still a very polluting process. Very often traditional technologies aim to produce as much as possible, and we will see that that's not a good approach. It's much better to be flexible and produce things when they are needed. After that, before getting into your house, someone needs to convince you that you actually need that product. And that's where marketing steps in. So the selling process sometimes is just a simple way to put together who's offering something and who needs something. In other cases, is a set of psychological strategies that really push us to buy more than what we need. This, of course, is one of the key problems in sustainability. Not the production in itself, but why do we buy what we buy? Thinking about the use of the object, that it's the next step, of course we can think about very durable objects, things that are meant to last, things that are meant to be upgradable or that I can improve or I can fix. In other cases, this is not true. Now, single-use objects is actually becoming less and less popular, and that's a very good thing. But in the past, we had ridiculous things like single-use cameras with the complexity and all the technologies needed to actually take decent pictures. More recently, there were cases of COVID tests that actually included electronics in a single-use object. The technology needed was only the small strip of reactive material inside. Everything else was, of course, a waste. At the end of this linear process, there is how do we throw away the things that we don't want? How do we get rid of what we consider a waste? Of course, the problems here are so many that it's just too long to name them all. But think about the space required for this process, the pollution created, the contamination of the soil, and so on. So thinking about how to reduce this is really a key aspect. So what is circular economy? We understood that linearity in economy is not a good thing, but what it really means to be circular. Well, actually there's more than one answer in that. In fact, there's this brilliant publication that explained that circular economy is an umbrella term. It means that it collects different models that have similar concepts in it. In this graph you can see how many different versions of the same concept has been developed during the years. So what are we going to use out of this definition, just to be sure that we speak the same language and use the same terms? Well, the model that is becoming one of the most common and well-known one is actually the one from the Ellen MacArthur Foundation. It describes in very simple ways what to do in the biological realm and in the technological one. What you can notice in these visualizations is that you have circles, loops that close on themselves, so this concept of circularity again, but these loops are with different sizes. So the smaller the loop, the better the strategy it is, the more impactful the strategy is. Because it means that we need less transformations, less transport, less actors to get the same result. That is to have the benefit of owning objects or services or technologies, limiting the impact of these products and services. So why we are going to use this model over others? Well, first of all, because it's very simple to understand it. So the key concept is to close the loops, close the circles. Whenever you have an open flow of material, an open flow of resources, where that's actually a design opportunity or a making opportunity if you want, something that we can intervene and fix or create solutions that might actually help in that direction. Second point that simplifies our designing process or creative process in general is that these strategies has a specific hierarchy. So it's easy for us to look at the graph and understand that we should first try to fix something instead of recycle it. So it gives us a sort of checklist. Can I do this? If so, perfect. That's going to be the most effective way to go. If I can't do the first strategies, I can move to the second one. If the second one is not feasible, I can work on the third, and so on. Last point, it's really about this concept of strategies. So the strategies are simplified approach to a problem. We will see 4 of them, but in different models there are maybe more or less. So the strategies gives us some key terms to think about when we want to find a solution. Last point, and maybe the most important one, we want to see this model through the lens of making. Not because we are passionate about it, of course we are, but because it's a different approach, an approach that sometimes is neglected or that not too many institutions or politicians or policymakers thinks about. It's not something that a company is looking at. It's not some of the problems that somehow someone else will fix. So what can we do? And I think that this is really a key point in the process. So what are the strategies that we were talking about? The first one is repairing. If something can be fixed, that's perfect. Let's extend its lifetime. Let's make it last longer. Second one is reduce or reuse. So whenever I have something that maybe I repaired, I can maybe use it in another way, or someone else can use it if I'm not interested in that anymore. Or I can reduce the amount of material or energy that this object is using when I'm thinking about it. The third approach is to recover. When we recover, it means that maybe the entire object is not working anymore, but there are still interesting components in it that could be regenerated or used in another project, or collected and sold as spare parts and so on. Only the last step, the less effective strategy, what we do when we have no other chance, is recycling. Very often we think as recycling as the keystone for circular economy and sustainability. Actually, there are things that works much better than that. Let's talk about repairing. Many services of repairing existed in the past. It was a very common thing to make things last as much as possible. More recently, we lost a bit that connection, but technology is bringing it back somehow. I often think about Makers and Fab Lab as a sort of intermediate level between larger community of people and higher level of society, such as policy making or big companies, or the economical world of the university in general. I place us as a community in that middle level, mainly because we have the capability of speaking both languages. So Fab Lab do a lot of training or educational programs, works on different fields, makes technologies available on one hand, but on the other it might bring innovation or new technologies or new ideas, bring startups to bigger companies, scale startups up. It might be the one managing and dealing with co-design for a municipality, or a co-creating process and so on. So in the circular economy, I strongly do believe that we have the same role. So whatever nobody else is capable of tackling, it's actually a great challenge for us. First of all, if we think about our users, the people that comes in Fab Labs Makers, so us as well, we are people that really want to be hands-on and be practical in things, and we have tools to do that. So we look for challenges, problems to solve that are around us. Of course, some of the problems are too big to be fixed just by you, but you can start to work on that and create a community around it, and we will talk about it later. Fab Labs can do the same thing on a different level, maybe increasing complexity, tackling what are called wicked problems, so the kind of problems that have no simple, singular solutions, and include more actors in the process, managing a level of complexity that a single maker might not be able to manage. Now, this is the point of view that we will use to filter and read through the strategies of circular economy. And let's talk about the first one. Repairing is the first thing that you should try to do with the product, and you should think about repairable products. So there are different services that work on that in the past, and then it disappeared for a while. Now it's coming back. The amount of products we throw away because they are not working anymore the way we wanted, or sometimes it's just because we don't like them anymore, it's huge, in particular in some areas such as fashion or electronic waste. Those are really, really big problems. So, 2 examples of what a maker can do in this area. Think about iFixit. Big service, online platform that provides thousands of tutorials that could actually help skilled people, but not necessarily professional repairers, to fix their own stuff. Another example is My Mini Factory, great platform that shares 3D files that could be easily 3D printed. They have a specific part dedicated to spare parts. Those kind of things that you can't find in a shop or they are super expensive. Well, it's enough that one of us as a community once designed the specific part that you need, and that's gonna be available for everybody. So those are just 2 simple examples of what you could do in repairing. Second one is reducing. So whatever doesn't exist is not gonna break. That's the motto that you should keep in mind when you create something. Keep it minimal, keep it simple, and make it only when it's needed. So the industrial model can be simplified with this graph that describes what's called the break-even point. In an industrial production, you want to produce as much as possible because you have a certain amount of fixed costs, plus a smaller amount of variable cost that depends on the number of pieces that you produce. So even if you set up a production and you start to sell the products, you're not going to be profitable or sustainable until you reach a certain amount of pieces sold. This is actually a problem because it forces companies to push product on us, to try to convince us that we need things that we really don't. So what can we do as an alternative to this model? Well, for instance, using digital fabrication technologies, we can produce things when we need them. One of the best examples is the Prusa factory, in which 3D printers are produced by other 3D printers. The factory started with few machines back in the days, and now they reached over 300, and it's growing. Whenever you have a new model, you tweak the 3D file, update it on all the machines, and start the production again. No molds, no limitations in change, no problem in scaling up production without impacting or redoing entire production lines. Next strategy is recovering. So what we do here is actually to take what's still good in projects and reuse it. I'm sure you did that in your Fab Lab or at home with the products that you're not using anymore, or with the first prototypes that you developed. Now, this is feasible in an easier way in our design because we work so much with open source, because we work around standard components that can be reused, that you don't have to throw away, with standard connections, with standard languages. Think about Arduino, for instance, the brain of a lot of makers projects. You don't have to throw it away together with the rest of your product when you're not using it anymore or when something breaks. That's something that can be easily programmed again. You might be able to change the carrier or the shield that you are able to make with a milling machine in your lab. So all the components can also be collected in some cases. This is a key point in saving components and parts of the project, of course, but it's also a key aspect in developing new projects. So this graph is an amazing representation of what open source meant in the past in the development of 3D printers. So you can see in 2005 there was just one model that was the one, the very first RepRap developed by Boyer, and in that moment the idea of sharing knowledge really triggered a movement that within few years became so wide it's basically impossible to map it. Consider that what's actually mapped here, it's up to 2012. Today this graph would probably occupy the entire room. Last strategy, recycle. When we think about recycling, we often think about big structures that take care of tons of materials per day. But we can also think about other ways around recycling, that it's to look at what's considered as a waste under a different light, so under the light of resource. A lot of researchers think that design and making has a huge role in developments of new materials. So think about this, for instance. It's a beautiful blue material created mixing the fibers of recycled blue jeans into slabs that can be milled and transformed into products. So you can test this process at home, you can work on that before getting to the industrial scale to prove that it works. The capability of producing a prototype, it's really the one triggering this innovation, for instance. We've seen the main strategies of circular economy, and now we will dig a bit into some examples of how makers and Fab Labs applied these strategies in their daily activities. So, if you're a maker, what can you do? You're just one single person developing your own ideas, maybe in your house or your small lab. Well, first of all, don't be a single person. The capability of makers is really about creating communities and movements around the things that they are passionate about. So, wherever you look around you, you will probably see things that you think are not going the way they should. Identify something that it's a problem for you, that it's on your scale, that you can try to fix by yourself, at least partially, to see what ideas could have an impact. Again, focus on the communities. Communities are fundamental to spread a change. Very often we think that a good idea will scale up and become a giant company or a unicorn in the world of startups. But that's not the only option. Sometimes a great idea just spread through the network because it resonates with great people. You have the circular economy strategies. Use them to build upon it, to build upon ideas, approaches that could be useful in your project. Whenever you're doing something, think, is it easy to repair? Is it easy to access it? Can I reuse the material after the project is not useful anymore? Will I be able to collect the components? Is that a standard one? Will it be useful for me in the future? Can I make it lighter? Can I use less material with the same results? Can I make it thinner? Or can I just skip this function because it's not fundamental, or connect it to my phone instead of having a screen to don't waste material again? So use the strategies as a sort of checklist to figure out what's the best way to proceed. You are probably a person that is passionate about more than one topic. Very often makers like technologies, but they are also interested in communications or AI or agriculture or chemistry. So use your capability of mixing different skills to find something that is unique to you, that you can contribute to. And of course, the fact that everybody is very happy to learn from the others and share the knowledge that they created is the key point to build a community first, and also to tackle a problem not by yourself, not being alone, but being part of a larger movement. A great example of this is precious plastic. It actually started as an idea of a brilliant mind, a designer and a maker that based his graduation thesis on the concept. Now, it could have been just a great project and end up like 1,000 other projects forgotten and not used, but because there was such a strong focus on engaging with other people, on building community, on finding people that were also interested in understanding how to tackle the problem of plastic, it became a global movement. Now, if you go on the platform, you can find design plans on how to build machines, suggestion on great projects that you could start to develop and sell to make it sustainable, example of other communities around the world. You have courses, you have connection, you have everything you need to start. So this is the right approach, the maker approach. Think about the impact before thinking about the investor or the business model. Then of course we have to be sustainable, so that's why we speak about circular economy. The platform, for instance, allows you to buy machines or construction kits to start making things, but also gives you suggestion on what kind of products are easier to sell and in which environment. So this aspect of economic is fundamental, but is not the driver. What if you are a Fab Lab and not a single maker? What if you manage a space in which a lot of people gather together? Well, then you can move things, let's say, a step forward in complexity and defining a research project or more ambitious, complex, long-term activities that will bring a benefit, again, to the entire community. So in OpenDot, what we repeat over and over and over is that we work with technologies and co-design. We use innovative machines and digital fabrication, but at the same time, we are able to speak with people and understand together with them what is their main problem, what is the thing that makes them behave in a specific way. Without understanding this aspect, you will always be a provider of great technologies that might not be as impactful as you hoped. So that's why it's so important to be able to leverage on the network, understand what other people are doing, contact them. I got amazing answers and suggestions from all over the world whenever I have a problem. And you can do the same. Be part of the network is really about the connections. Networks are not just digital and global, they are also physical, made out of people locally. So whenever you do something, create partnerships, start to discuss with people in your neighborhood that might have the same goal and a very different approach from yours. This will definitely bring you to develop solutions that you will not be able to develop with your own strength and resources. I will give you just two simple examples of two different output of different research projects that we ran in OpenDot. The first one is Biomaterioteca. It's an open and freely available document that collects all the basic information about biomaterials. Biomaterials are a huge, amazing area to explore, and they could be so impactful because of the kind of material you use to make them, but also because of how they behave. The fact that you can design their durability, the fact that you can dispose them in an easier way or recycle them in an easier way. Now, this topic is very, very interesting, and there are research centers working just on that. So why we developed something like this when there are research centers working just on this topic? Well, we had a different objective. So we target students, craft people, artisans, local makers, people that might be interested in integrating these solutions, but they don't have a research and development office, for instance, or they can't afford to buy a minimum amount of 3 tons of bioplastic for their project. So we first described what is a biomaterial, how it works, what are the components, how can you change some details and fine-tune the recipes to improve the final result, as well as some products that are already available on the market that you could easily buy, and we specifically selected products that are available even on small quantities, so that you can really just experiment with them. So it's a simple example, not very technological, there's nothing related to digital fabrication, for instance, but it will empower other people to use digital fabrication as well, to make their own product in a more sustainable way. Second example is Botto. Botto is a technological solutions that facilitate donations of food that couldn't be sold in the general market of Milan. So the key point here is that the general market of Milan is the largest hub in Milan that buys and sells food, and we are talking about approximately 2,000 tons of food per day. Out of this huge amount of food, there is a small percentage that gets wasted, sometimes because it gets spoiled or is not good anymore, but very often it's just a defect in the packaging or some documents that don't match properly, so it couldn't be sold, or people just don't want apple in that period. So these could become donations for families that are in need, and the kind of donation that will really help them a lot. There are associations working already on the field to facilitate this process, and they collect donations on one side and redistribute it on the other. The problem is, it's a complex system. The wholesalers don't have time to deal with donations. The associations are not always present, or they are not always reactive. Some associations are working as a sort of coordinators, and they have to distribute what they collect to others and so on. Plus, this process has no data collection at all. So basically you don't know exactly how much food is saved or donated, beside, of course, the report of the associations themselves. So Botto is a simple solutions. It's basically a device that gets installed in the wholesaler stall with 2 buttons. You just press a button to say, I have something to donate, use the second one to give a rough idea of the quantity, and that generates a message on an automated chat of the association that can actually say, answer and saying, yes, I'm coming, and pick up the donation. If that happens, Botto gives a feedback to the wholesaler that knows that product shouldn't be thrown away. This is a starting point. The process is kind of articulated and long, and we really developed it through co-design together with the people. At the beginning, we thought that an economical incentive might help to get more donations. So what if we pay a bit for the food that you donate? Will you be willing to donate more often? What if we reduce the taxes that you pay on food if you donate something. But these kind of incentives were not the key point. The key point that emerged through co-design was really the fact that wholesalers are very busy people, and you can't ask them to invest their time in something that is just out of goodwill. So simplifying the actions through technologies enabled new actions that were more sustainable, changed their behavior, and that was the key of the entire process. Out of the data that we collected, we can say that these simple solutions might be able to save tons of food per day in average all over the year. Simplifying also the actions and activities that the organization have to do daily. So to conclude, these are just some examples, and I hope you got ideas and suggestions and the will to actually experiment something on your own, something that you can actually make with your hands, with your capabilities, with your community, with your network, that could scale up and have a bigger impact, or just stay local and have a local impact as good as the global one. So thank you very much, and I hope you are gonna make impressive, scalable, impactful solutions that one day I will replicate myself. Now, how can you try to apply what you just learned in a practical way, the way we like? You can choose these two formats that will guide you through the design process, and you can keep them as a sort of checklist whenever you're making something. The first one focuses on makers. So you have your own project. Please keep in mind that you can tackle a problem that is on your local scale but could be bigger, as well as keep in mind of involving communities and make things in a way in which they are replicable for others to actually get enthusiastic and build upon it. This is just an example. Please check the format with all the suggestions and think about how you can steer the direction of your project to fit better the strategies and to fit better the suggestions. Second, if you are a Fab Lab manager or you work in a Fab Lab, please consider, beside the things listed in the Maker form, also the things listed in the Fab Lab form. It includes, for instance, are you engaging with people in the right way? Are you coordinating a larger network of entities and associations that wants to contribute to the same goal? Are you thinking about how to empower the people on the field and how to share knowledge and not just solutions? So again, check the entire list of questions and use them as a memo note somehow, as something to think about whenever you will develop a new sustainable project.